Hi everyone. Today what we're going to do is determining polynomial equations, and we're going to do it from graphs and from tables. So the other day we had worked out the graph from the equation. We're going to work backwards first. So the first thing I'm going to do is I'm going to label the roots or zeros of the x-intercepts. So I've got one here at -2 and 0, and I've got another one here at 1 and 0. And then not only are they zeros or roots, this one's like a little parabola here, so that's going to become order 2 because it looks like a little parabola. And this guy here is like a little cubic, so it's going to be order 3. So when I go to put that back into the equation, that's going to tell me what the exponents are on that zero, on that factor I should say. So I'm going to take this, put it back into the equation, so I'm going to have f at x equals, I don't know what the leading coefficient is. I have no idea what that is, so I'm just going to put a for that. I know that this 0 of -2, or this x-intercept of -2, is in a factor. It's going to look like x plus 2, because it's always the opposite. And it's order 2, so it's going to be squared. And then I do the same thing with this one. So it's going to become x minus 1. And then it's order 3, so it's going to be cubed. So it's going to look like that. And what I need to do is I need to figure out what this coefficient is, what this a is. And what I have to do is I have to pick one of the points on the graph to substitute in for x and y in order to figure out what a is. So if I substitute an xy point, I'll know this and this, I'll know these x's, and I'll know the y value, and I should be able to calculate a. I can't use the 0, because if I did, look what would happen. I would have y would be 0, so I'd have 0 here. X is -2. If I replace this x with -2, I'm going to have -2 plus 2, which is 0. 0 squared is still 0. 0 times a is 0. The whole thing goes to 0. So I get 0 equals 0, which is true, but it's not very helpful. So I'm going to pick this point here, the y-intercept, only other point that's on here. And the y-intercept is 0 and -2. So I'm going to substitute in 0 and -2. Sub and 0 and -2. So I've got -2 equals, I still don't know what a is. I'm going to have 0 plus 2 squared and 0 minus 1 cubed. -2, nothing I can do with that. Still don't know what a is. But I know that 0 plus 2 is 2 and 2 squared is 4, so that's going to be 4. And for the next part here, I've got 0 minus 1 is -1. -1 to the power of 3 is -1, so I'm going to have -1 there. And I just multiply those guys. -2 equals -4a. I could have put a times -4, but usually you write the coefficient in front of the letter, so the number goes first. Divide both sides by 4, and you'll get a equals 2/4, which reduces to 1/2. So now I know, therefore, f at x equals 1/2 x plus 2 squared, x minus 1 cubed. And that's how I go about finding the formulas from the equation. So you can rewind this whenever you need to, go back to where you need to, but the quick overall of what we did here: find the zeros, plug them into the equation, get the order just by visually checking order 2 because it's like a little parabola, order 3 it's like a little cubic. I didn't know what a was. I used another point on the graph. This time we happen to be given the y-intercept, so I used that coordinate to solve for a, and we're done. Okay, for the next one, example 2, same idea. I've got a 0 here at 0, 0 right at the origin, and I've got a 0 at -2 and 0. And I've got this other coordinate here, -1 and -1. The other thing I should note is this is like a little parabola, and this is like a little parabola, so they're both order 2. Same with this, order 2. So I'm going to substitute that in to the equation. So I have f at x equals, I don't know what the leading coefficient is, so I'm just going to have a. This 0 here would become x plus 2. And it's order 2, so it's going to be squared. This one here would be x plus 0, or just x. And again, it's squared because it's order 2. I'm going to do some simplifying here. So f at x is equal to a. This is just going to become x. X plus 0 is x. It should become x squared. So we put ax squared. Usually that's put up front. And then x plus 2 squared. Just like we did last time, I'm going to use this point. So this point now is not the y-intercept, it's just another point. If I use the y-intercept, that's 0, 0. If I did that, same thing as we had up here, it's a 0. It's going to give me 0 for the y value. This is going to be 0 squared. 0 times anything, 0. And I'm going to get 0 equals 0. Not that helpful. So I'm going to choose to use this other coordinate here, -1, -1. Move it up a little bit. So I'm going to say sub n -1, -1. So we're going to have -1 for y, or f at x, equals a times -1 squared times -1 plus 2 squared. Just do some simplifying here. -1 is equal to a. -1 squared is 1. -1 plus 2 is 1. 1 squared is 1, so it's just 1. And then I've got a times 1, which is just a, so I get a equal -1. Okay, and that matches the graph. A is -1 would tell you that it's going to be like a parabola opening down. It's flipped, so it should have end behavior going from quadrant 3 to quadrant 4, and we do. Quadrant 3 does a little weird little blip, and then down to quadrant 4, so that seems to match. So then our overall equation will become, therefore, f at x negative, I'm not going to write the 1, so negative x squared bracket x plus 2 squared. And you can substitute this into, I'm not sure why I wrote that on an angle, but you can substitute this into Desmos, and it should match this. I did it before I started recording this, and it worked fine, but double check it in Desmos, make sure it works. It should match. Okay, so that's 2 examples of trying to find the equation from a graph. The key points are the zeros and another point. One happened to be the y-intercept, one wasn't, but it's the same idea. So next thing we're going to do is determine the equation from a table. So it's very similar. One thing to notice really quick is, so determine the equation for the quartic. It tells us it's a quartic. Quartic polynomial function represented by the table of values. So I know it's a quartic. The other thing I noticed is this is an even function. And how I can tell it's an even function is if I take f at -3, that's equal to 91. That's the same as f at +3. Same idea for -2 and +2. F at -2 is equal to 21. And that's the same as f at +2. So if you look at your definitions from yesterday, an even function, you have f at -x is equal to f at x, and that's what these are telling us. So what that means is f at -1 and f at +1, if I compare those two, they're both 3. F at +2, f at -2, they're both 21. That's kind of what I'm looking at. So I know that this guy is even. Okay, so that's going to be very helpful. So what that tells me right away, if it's even, is I know I have no negative exponents. So I know it's a quartic, so power 4. I know there's no to the power of x to the power of 3's and no x to the power of 1's because I can only have even exponents. The other thing I can notice on here quickly is this point here. Since x is 0, that's the y-intercept. 0 and 1. That's going to become helpful too. So I'm going to take this information and I'm going to put it together with what I know about it being quartic. So I know f at x is equal to ax to the power of 4 plus bx to the power of 2 plus c. And there would be an x to the power of 0 here because it's an even function. I don't need to worry about x to the power of 3 or x to the power of 1 because if it's even, there are no odd exponents on x. So what I can do is this. I know the y-intercept is 0, 1. That's C. If I let x equal 0, this equals 0, this equals 0, that has to be 1. So this has to be 1. So I know C right away. The other thing I need to find is A and B. So A I can find by using the formula when we did the first differences. So the differences are equal to A times n factorial. So I know n is 4 because it's a quartic, so 4 factorial. But what I don't know is the differences. So I'm going to have to work out the differences. I just realized that that's what I wrote, how I wrote on there is not the best thing to do. So I'm going to cover that up with a piece of paper. Not ideal. And I will work out the differences. So I know 21 minus, we'll go bottom minus top, so 21 minus 91 would be negative 70. 3 minus 21 would be negative 18. And you just keep going. So 1 minus 3 is 2, 18, and 70. So not equal, which you would expect because it's not linear. So this one's going to become negative 18 minus negative 70. Be careful with the negative. So this is 52. Negative 2 minus negative 18 is 16. It's 4, 16, and this is 52. Okay, second differences are not equal. It's not quadratic. So we'll go to the third differences. So I get 16 minus 52 is negative 36. Negative 12. This would be 12. This one would be 36. Third differences are not equal. It's not a cubic. We know it's quartic, so these have to be equal. Negative 12 minus negative 36, that's 24. 24 and 24. So these are all difference. These are all equal, I mean. So now I can work out differences equal to A times n factorial. So I know the differences are 24, so 24 equals A we don't know. And we know it's a quartic. First, second, third, fourth difference are equal. It's quartic, so n is 4. It also tells us in the question that it's quartic right there, so we know it's 4 factorial. 4 factorial, if you punch into your calculator, is 24. So this is 24 equals A times 24. Divide both sides by 24 and you get A equals 1. So now that tells me that I know f at x is equal to 1x to the power 4 plus bx squared plus 1, because we knew the y-intercept was 1. So I still don't know b, but what I can do now, I know if I take one of these coordinates, I know everything except for b. So if I take the coordinate, let's say we take the coordinate 1 and 3, so I'm going to sub in 1 and 3, and you could do this with any coordinate, it doesn't have to be 1 and 3. It just shows it because they're positive numbers and they're small. I don't want to deal with big numbers if I don't have to. So I know that y is 3 equals 1 to the power 4 plus b times 1 to the power 2 plus 1. Just doing some simplifying. 1 to the power 4 is 1. 1 squared is 1 times b is just b plus 1. Collect like terms. I'm going to have 3 equals 2 plus b. Subtract 2 from both sides. I should get 1 equals b. So now I know a, I know b, I know c. So therefore, f at x is equal to x to the power 4 plus x squared plus 1. And you can check this on decimals if you want. So you plug in this equation. It'll give you a graph. You can check the coordinates from there. There's a way on decimals actually to graph it, and then click on the little settings gear. You can change it to a table of values, and you'll see these numbers in the table of values. So it does work. Just click on tables, or you can try substituting some of these in and it'll work. Okay, so how do we do this? So first thing we noticed is that it was even, and I had it covered up here, but it's even. So that tells me I don't need to worry about any odd exponents. I know that the y-intercept was 0 and 1. It happened to be on the table, thankfully. So that told me what the c value was here. And then I used the differences. And I worked out the fourth differences for 24. I used the little formula from the differences to calculate a was 1. And then once I knew a was 1, I substituted in a point, and I solved for b. And that gave me the equation. Okay, hopefully you find this helpful. can do some independent practice on page 40. Good luck.